Hello everyone, you're very welcome to this webinar on descriptive statistics illustrated with XLSTAT. My name is Jean-Paul Maalouf. I'm a statistics consultant in the XLSTAT company, and I will try to be as intuitive as I can. I'll try to avoid as much as possible within this webinar to use complex mathematical formula and just to let you become independent in using different descriptive statistical tools in case you're not already more or less used to them. At the end of the webinar there will be a Q&A session, so you're able to ask all your questions all along the webinar using the chatting window. There will be a recording of this webinar available starting from tomorrow, so you will receive an email with a link to the recording. And also, you're able to download handouts presentation within the handouts section. So you have a handout section in the webinar platform in which you can download the presentation as well as the data we're going to use. So here's the webinar plan. We'll start with a brief introduction on XLSTAT and with a historical overview. And then we'll talk about statistics, a couple of definitions, and I will tell you my way of categorizing statistical tools into different sections, different sectors. We'll talk about variables, individuals, and after defining variables and individuals, we will take each of these situations and try to see how we're able to describe data that is made of one qualitative variable, then two qualitative variables, then one quantitative variables, and so on. So we'll investigate each of these situations with an illustration using the XLSTAT software. So all the data in this webinar were made up unless otherwise specified. Who are we? So XLSTAT, for those of you who don't know us yet, is a user-friendly statistical add-on software for Microsoft Excel. So those of you who haven't seen how it looks like, you will have the opportunity to see it right away during the webinar. So here's a brief historical overview. Everything started in 1993. The first sale occurred on the internet in 1996. Then the Addinsoft company was founded in 2000. It's the current company that hosts the software. In 2006, we had a new version that split the code into two languages, so VBA and C++. Then in 2009, we had new offers adapted to business needs that were reshaped, rethought, within new products that were released in 2015. Then last year, we released the cloud version of XLSTAT, which is XLSTAT 365, that allows you to use XLSTAT on Excel 365 on the internet. And we also released a free edition of XLSTAT named XLSTAT Free. Actually, it's an edition that lets you run a limited number of features, so 13 features in total, on your data without having to purchase an XLSTAT license. And now, within a few weeks, we will be releasing a big surprise. I won't tell you more about it, but stay tuned and you will know what will be released. In a few numbers, XLSTAT holds more than 200 statistical features. We have more than 100,000 users across the world. We are 22 employees. The language is available in 7 languages. We have 220 visits a month on the website and 10,000 downloads per month of the software. So now let's switch to the subject of this webinar. Here's a basic definition of statistics. It's the science that deals with the collection, the classification, the analysis, and the interpretation of data. Now, let me tell you about my way of categorizing statistical tools into 4 different sections. So there are several ways of categorizing them, but I find this way quite simple to explain things. So first we have descriptive statistical tools that let you summarize very simple data sets, very small data sets, using simple statistics or charts, like the mean, the standard deviation, or box plots. So data sets with 2 or 3 or 4 columns can be described using the descriptive statistic tools. Then exploratory data analysis allow you to easily extract information from a wide data set without necessarily having a precise question to answer. So here we find the principal component analysis or clustering methods such as agglomerative hierarchical clustering and k-means and so on. So here we have exploratory data analysis is part of what we call data mining. So you have a huge data set, you don't have a precise question behind your head, and you just want to dig in your data set to try to extract some interesting information. Then statistical tests allow you to accept or to reject very precise hypotheses, assuming error risks. So compared to exploratory data analysis, statistical tests involve a very precise question whose answer is yes or no, and help you answer this kind of questions. So tests include the very famous t-test, ANOVA, correlation tests, chi-square, and so on. Then modeling tools help you understand the way a phenomenon evolves according to a set of parameters, like regression, ANOVA, or ANCOVA. So all of these tools or of these sections are not really disconnected. As you can see, the ANOVA can be found in the tests and in the modeling. Modeling tools can be also used for exploration. But I think this way of representing things, of dividing the statistical methods, is quite convenient for understanding everything. But just don't think everything is disconnected. You have many connections between the categories. So today we will focus on descriptive statistics. So this first section or category. We have webinars on exploratory data analysis, statistical tests, statistical modeling, and ANOVA, which is part of modeling, coming soon. So don't hesitate to subscribe. There will be a story linking all the webinars to each other, so to one another. So don't hesitate to subscribe to them in order to have an overview of all the standard statistical methods you may have. So let's switch to basic definitions of variables and individuals. What is a variable? A variable is an element that can take different values. So this variables can be quantitative, which means that they can be quantified. Quantitative variables are represented with numbers that you can add, that you can subtract. For example, we can think about invoice amount, the number of likes on Facebook, the sugar concentration, the height, the weight. Then qualitative variables, in contrast, also called categorical variables or nominal variables, are variables that cannot be quantified. So for example, the socio-professional category, the geographical origin, the type of license, the blood type. And then all the possible values a qualitative variable can take are called the categories or the modalities. So blood type can be A or O or AB. Those are the categories or the modalities. Individuals are elementary statistical units that can be described with variables. So customers can be described by the invoice amount they pay. The surveyed people can be described by the answers they give to the questions we ask them. So those questions are qualitative variables or quantitative. Patients can be described by their height or their weight. Laboratory mice can be described by their genotype or by their variety, and so on. So now we will switch to a data set that we will be investigating all along the webinar. So this is data relative to clients, to customers of an online shoe selling platform. Here, in most cases, the data tables are represented this way. So in rows you have the individuals. Here our individuals are our clients. So most of the time we represent individuals in rows. And those individuals are described by several variables in columns. So here our clients are described by their origin, their gender, their height, their shoe size, weight, time spent on the website, preferred brand, and invoice amount. As you may have noticed, we have qualitative variables here, like origin or gender, and you also have quantitative variables such as height, shoe size, weight, and invoice amount. So we'll be playing with this data set all along the webinar. First thing we will do is describing one single qualitative variable. We'll focus on this column. How can we describe this variable, and what can we extract, what interesting information can we extract from this column using statistical methods? So we will use methods such as sorting or mode. Let's go. So here you have the way things can be configured in XLSTAT on the data if you want to follow the webinar on your own, on your computers. So here we go. This is XLSTAT. It's an additional tab to our Microsoft Excel file. And each of those menus include several statistical features that you can use directly on your data in Excel. Here I want to describe this column. So I will go to Describing Data, Descriptive Statistics, and here I have the dialog box that opens, the Descriptive Statistics dialog box. I want to focus on qualitative data, so I just switch off the quantitative data field and I click on qualitative data. Actually, I will reset the dialog box, it will be easier. Okay. So I click here and I just select this column like this. I can also select it like this. So data selection is quite straightforward. There are options I can configure and outputs. Here I need to choose the outputs I want to see. There are two windows within the Outputs tab. One window for the quantitative data, which was switched off, so it's in gray here, it's deactivated, and one window for qualitative data. So within this window, we will choose the statistics we want to see, the numbers we want to see to describe our column. So here I just click on None, and I will take the number of observations, the number of categories, the mode frequency, the categories, the frequency, and the relative frequency. In the Charts tab, I will activate the bar charts. And then I click OK. Here, as you can see, the results appear in a new Excel spreadsheet. So here you first have one table that lists the variables you are describing. Here there's only one variable, the preferred brand. And then you can just expand those columns to see the titles and investigate all these descriptive statistics. And so I will comment on these numbers. The number of observations is simply the number of rows in your dataset, or the number of individuals you have. The number of categories of your qualitative variable is 4. So this means the preferred brand column, the preferred brand variable, contains 4 categories. So we have brand A, brand B, brand C, brand D. Brand C is the mode. The mode corresponds to the most common category within your variable. So brand C is the preferred brand in your customers. The mode frequency is the number of times the mode, the category associated to the mode was selected. So brand C was selected 12 times. Then you have the frequencies per category. So here, as you can see, brand C is the maximum. It's the mode. Brand A has been selected 10 times within the 30 customers. Brand B 4 times, C 12 times, and D 4 times. Then here you have the equivalent in percentages, the relative frequency per category in percentages. And right below, you have something called a bar chart, which visually lets you see which brands are higher or taller than the others. Here you have the frequencies per category, and as you can see, brand C is the most popular category, as we've seen earlier. Well, this chart can be more interesting when you have many more categories. So for now we only have 4. It's not that interesting. If you have many, you'll be able to easily detect the high categories from the low ones. So here we go. As I told you, the mode is the most frequent category. And here you have the counts per categories, which are called, in statistics, sorting. So we just did the sorting here. Then here you have the bar chart we've seen. So it was very interesting to describe the preferred brands within the whole set of customers. Now how about describing the link between 2 qualitative variables? In other words, how about splitting this preferred brand column according to other qualitative variables such as the gender or the origin? So it could be more interesting to study the preferred brand according to origin. So we are investigating in a way the link between 2 qualitative variables. So to do this, I propose to run crosstabs or cross tabulations, or also called contingency tables in statistics. So here's my data set again. We'll focus once again on the preferred brand, and we'll split this column according to origin or gender. We'll try to see if on Pluto people prefer brand A, or if on Mars people prefer brand C. So this could help us better design our marketing campaigns. So to access the contingency tables or the crosstabs, you need to go to preparing data and select create a contingency table. So I'll run this on XLSTAT. So I click on preparing data, create a contingency table. In the row variables field, I will select the preferred brand. Then in column variables, I will first select origin. So we'll understand what I mean by row and column when you see the results. Then there are options I can select within this tab, and the outputs. Here again, I will select some outputs that might seem strange to you, but it will be much clearer when you see the results. So I click on OK when I'm ready. Here's our crosstab or our contingency table that appears once again within a new Excel spreadsheet. Here in rows, we have our row variable, which is our preferred brand, and which is split according to its categories. So brand A, brand B, brand C, brand D. And then the origin variable is split into 3 columns: Earth, Mars, and Pluto. And then at the intersection of each row and each column, you have the count or the frequency of customers corresponding to the 2 categories. So here we have 4 customers from Earth who selected brand A. We have 1 customer from Mars who selected brand B. Here we can start seeing that on Earth, brand C is the most popular and brand D is the least popular. On Mars, brand A and brand C have ties, and so on. So maybe it's more convenient to represent things like this with percentages. When numbers start becoming more complex, when you start having higher numbers and it's more difficult to appreciate the proportions, maybe this representation is becomes more appropriate. So here we have 50% of customers from Earth who selected brand C and 0% who selected brand D. So here it would be what we can conclude from this as from a marketing point of view is that it's really not worth it to focus our marketing efforts on brand D on Earth. But it's more interesting to focus efforts on brand C instead. So we have investigated the link between 2 qualitative variables, preferred brand and origin. So it's also very simple to generate this contingency table on the gender, and even you can automate things in XLSTAT. So if you select origin and gender in the column variables and you click on OK, here you will have 1 contingency table per combination of variables. So you have 1 for origin, and here you have 1 for brand. So things can be easily automated here. Now it's time to start describing 1 single quantitative variable, and we'll use popular statistics such as the mean, the median, the standard deviation, and we'll see also 1 mainstream data visualization tool, which is the box plot. So imagine you have the shoe size data, which is spread on an axis. Here you have your different values of shoe size, and you have our different customers that are placed on the axis like this. How can we describe this series of quantitative values? The first thing that could come to your mind is using statistics that measure the central tendency of the data, such as the mean. We all know the mean. It's a very, very popular way of describing a series of quantitative data. There's another way also to describe the central tendency of a series of data points, which is the median in blue here. So what is the median? The median is very simply the middle data point of your series. So the data point that splits your data into 2 equally sized data sets. So here we have 50% of the data to the left of the blue dot and 50% of the data to the right of the blue dot. In what cases can we use the median instead of the mean, and what case it's interesting to use the median instead of the mean? The median is very insensitive to extreme data points. So here, imagine this abnormally sized shoe. Imagine if it was even further, or if it was closer, the median wouldn't move. The median will always be the middle data point. So it's very insensitive to extreme data values. So if extreme data values are not really important in your measurement of the central tendency in your data, I advise you to use the median. Whereas if those points are very important, the values of those points are important, maybe it's better to use the mean, because the mean will be sensitive to these data. If this dot was here, or whether if this dot moves from here to here, the mean will move slightly to the right, whereas the median will stay where it is. One first way of describing a series of quantitative data is measuring the center of the series. There's another popular way of describing a series of quantitative data, the description of what we call the dispersion of the data. So to what extent are the dots or are the data spread around the mean or the median? So here each arrow represents the distance between each dot and the mean. We can have situations where the points are narrowly distributed around the mean, and other situations where they are more widely distributed. So why is it interesting to measure this dispersion? In our case, for example, imagine you had a very narrow dispersion of your points around the mean. In this case, you know that most of your clients don't really have a very wide range of shoe sizes. So in your warehouse, you wouldn't need to have many shoe sizes that are too extreme, under 25 or over 35. Whereas if your dispersion was too wide, you will need to have in your warehouse a wide amplitude, also a wide variety of shoe sizes. One of the most popular ways to measure this dispersion is to measure the mean, the average of these arrows. So this is a very, very simplistic way to say what is a standard deviation. So I'm really sorry if there are statisticians in the audience. Another way to measure this dispersion is using the variance, which is the square of the standard deviation. So we've described our data series using the central tendency and as well as the dispersion. So let me show you how we can launch the computations in XLSTAT. So I'll go back to describing data and then descriptive statistics. And here I will switch off the qualitative data and select shoe size under the quantitative data. If I go back to outputs, the qualitative data window was turned off and the quantitative data window was activated. So here I will select different statistics I want to see, so number of observations, the minimum, the maximum. I can select the median, the mean, the variance, and the standard deviation. And I click OK. So first I have a summary, the numbers I asked for. Here you see that the mean and the median are very similar. We have the minimum, the maximum, the variance, and the standard deviation. And you also have this very interesting representation, which is the box plot. The box plot is very important as it really sums up many interesting information relative to the central tendency and the dispersion of your data. So I will comment on the box plot using my presentation. So here's my box plot. On the y-axis, we have the variable that we are describing. Then, let's start from the extremes. These gray dots are the minimum and the maximum. Then, in the middle bar here in green is the median. As I told you, the median is the point that will split your data into two equally sized data sets. So below the median, we have 50% of our data, and above the median, we have 50% of our data. So I think you've all guessed that this orange dot is the mean, which is very close to the median in our case. This is often the case when your data are symmetrical. Then we have important statistics, which are the first quartile and the third quartile, which are those bars, which are the extremes of the box. The first quartile is the data point that splits the data into two parts. You have 25% of the data underneath and 75% of the data above. Similarly, the third quartile splits the data into two. You have 75% of the data below it and 25% of the data above it. So here you can see that the data is split this way using the quartiles and the median. Well, the quartiles help you evaluate the dispersion of your data. Here you can see that you have 25% of your data that is very spread at this extreme compared to the middle. Here you have 50% of your data in a very narrow interval, whereas here you have 25% of the data in an interval that is even bigger than this one. This is a clue that tells you that your data is concentrated in the middle, around the mean and the median. So the quartiles allow you also to check the dispersion of your data. Then finally, you have the whiskers, which are often set as the Taki limits. The whiskers are, in a certain sense, the boundary between the bulk of your data and potentially extreme data points. So as soon as you have data points, or the maximum or the minimum, above one of the limits, above the upper limit for the maximum and below the lower limit for the minimum, some people consider that those points are outliers or are too extreme. So here we see that the maximum is above the upper whisker. This means that we probably have outliers. So data that are potentially too extreme. This is one of the ways to check for outliers. It's not a standard way to do it, but some people use it to detect their outliers. So we've seen that the box plot really summarizes many interesting information in a single, easily to read chart. So before describing the link between one quantitative variable and one qualitative variable, I will answer the first set of questions. Can you show us how to make a means table with subcategories such that the output might look like a pivot table? So good news, we'll see this in the following section. Why does not the column add to 100%? So here in our contingency tables, here, somebody asked, why does the column not add to 100%? Maybe you meant the row. Like here, for example. Here, if you add up this, the percentages in this row, you get 40%. Well, you can, it's very simple. You can compute the percentages per row or the percentages per column. If you're more interested in splitting your data into different brands within each category of origin, you better compute your percentages per column. But if it's the other way around that's interesting to you, you can also compute your percentages per row, and this is very easily configured using the outputs in the contingency table dialog box. So here you can compute also the percentages per row. Any resources for best practices for preparing the data set, the input for XLSTAT? The best way, I think, preparing the input data for any statistical platform, any statistical software, not only XLSTAT, is really follow this rule, to put the observations or the individuals in rows and their descriptions in columns, the variables in columns. So describe your individuals in rows with variables in columns. So this is really a rule of thumb for handling, for preparing a data set for analysis using a statistical software, not only XLSTAT. How are the Tukey limits derived or computed? So there's a specific formula for which is very simple for computing the Tukey limits, and that is available within the XLSTAT help section. So just click here and go to visualizing data and univariate plots, and look for the limits within here. I think they're in the description section. Can you show the box plot graph including the standard deviation apart from Q2, Q3? Well, classically the box plots do not include standard deviations. So theoretically we cannot include standard deviations or variances within box plots. Would you suggest to eliminate the data outside the Tukey limits? Here I would say it depends on your field of expertise. If you see that there's a data point which is above or below the whiskers, I think you just need to check what this data point is about. Is it an error in your Excel file? Did you have an error while entering this data point, or was this individual special or not representative of the population? If that is the case, you can withdraw it, or otherwise, if it's important in the representativity of your population of clients, you should be keeping it. But thank you for your questions. I'll carry on now. Now we'll talk about the description of the link between one quantitative variable and one qualitative variable. You can either draw multiple box plots for this, or compute quantitative statistics per category, which was suggested in one of the questions. So there's a very simple way to see that, to represent this link, it's to use multiple box plots. Here we are investigating the invoice amount on the y-axis. Sorry, I don't have the label here. We have the invoice amount, which is a quantitative variable, according to Earth, Mars, and Pluto, according to a qualitative variable, which is origin. We are describing the link between those two variables. What you can conclude by looking at this chart is that Plutonians tend to spend more money on the website compared to Earth, to people from Earth and to Martians. You can see also that Martians have a narrower range of invoice amounts, whereas the Pluto customers have a wider range of invoice amounts. And then things can be represented in a form of pivot table also like this. So I will show you how we do it in XLSTAT, and I will slow down because this was requested by one of you. So I will go to describing data, then descriptive statistics. Here I'm back to my descriptive statistics dialog box. I'm interested in describing the invoice amount variable, so I will just select it like this within the quantitative data field. I want to split this invoice amount according to subsamples. So I activate this subsamples option and I click on origin. I want to split invoice amount according to origin. Then in the outputs, I will select all the statistics I want to compute per origin on the invoice amount. So I have the mean, the median as usual, and there are many other things I can compute. And also in the charts, I can ask for box plots, which I want to group within the same chart. So this is configured under the Options tab. So I click OK. check this out. Here we have each category of origin, so Earth, Mars, and Pluto. And we have all of the quantitative statistics computed within each category. So we have the minimum, the maximum, the median, the mean, the variance, and the standard deviation. Here you can see that Pluto have the largest invoice amounts on average. But they also have the widest range of invoice amounts according to standard deviation and according to what we have seen on the box plots. This confirms what you have seen in the box plots. So we've just studied or investigated the link between one quantitative variable on the y-axis and one qualitative variable on the x-axis. Now imagine we switched to a quantitative variable on the x-axis. What will happen? How about using a quantitative variable on the x-axis instead of origin? Thus, we are going to describe the link between two quantitative variables using what we call a scatter plot. Here's what a scatter plot looks like. So you have the invoice amount on the y-axis and the time spent on the site on the x-axis, which are two quantitative variables, and then you have the corresponding individuals that are spotted on the chart. How can I obtain this using XLSTAT? So here I will go to visualizing data, scatter plots. I select what I want to see on the x-axis here. So this will be the time spent on site. On the y-axis, I want to include the invoice amount, like this. And then I click OK as soon as I'm ready. So here's my chart. So what can I say out of this chart? One of the most obvious things we can say is that invoice amount decreases with time spent on the website. For high values of time spent on the website, we have low values of invoice amounts. Now let us add an interesting information on this chart. An information that we will include in the groups section. How about adding a coloration according to origin? So I want to color the dots according the clients according to their origin. Here we have Pluto clients in gray, clients from Earth in blue, and Mars clients in orange. So here we are adding the information carried by one qualitative variable on the scatter plot. So we are already investigating the information coming from three different variables on the same chart. This is very interesting. So this can be done if I get back here and I click on Run again. I will just add groups in here, origins. So this will let me color each origin in a different color. So what can I say more than what we have already said? So invoice amount decreases with the time spent on the website. You can also say that Plutonians spend more money on the website compared to others. Look at the Plutonians who tend to have higher invoice amounts. The Martians and the humans form a relatively homogeneous group. They are all mixed up in here. So all of these statements were extracted from one single chart. And this kind of reasoning, we will have it in our upcoming webinar, which investigates exploratory data analysis tools. Now imagine this kind of reasoning on a bigger data set. Here we are only investigating three variables. There are tools that will let us have the same kind of reasoning of exploration, of fishing for information like this, but on bigger data sets. So we'll be able to investigate like 10-column data sets or 15-column data sets using very simple tools that will summarize the information within few charts. So we'll talk about this in the upcoming webinar, which is on exploratory data analysis and which will take place on October 26th, so next week. You can subscribe by clicking on this link. So in summary, we've seen how we could describe data sets with 1 or 2 or 3 variables. And this can be used to look for statements or hypotheses or to look for information. So all of these statements we've seen here are more or less hypotheses. We've explored simple data sets. Now, exploratory data analysis tools will let us dive or dig in bigger data sets and have the same kind of reasoning to look for, to fish for hypotheses. Then statistical tests will let us test these hypotheses, and this will be the webinar that's planned after the exploratory data analysis webinar. So don't forget the upcoming webinars. You can subscribe by clicking on these links. So this is the take-home message. We've seen many tools in different situations. So in a situation where we wanted to describe one qualitative variable, situations where we wanted to describe the link between 2 qualitative or 2 quantitative variables, and so on. So this is a summary slide that you can use. And at last, let me show you this interesting guide that we've just released on our website. So that's a guide that will let you choose the appropriate descriptive statistics method according to the data you have and the question you're asking. So it's available for free on our website. You have a grid that shows you different types of data on the left. So if you have one quantitative variable, what you can use with an example and the objective. All of these solutions can be clicked on to see how to apply things in XLSTAT. So don't hesitate to share this grid for people who are interested in descriptive statistics. So thank you all for attending. Don't hesitate to download the 30-day free trial if you haven't done so already, and click here to discover our product. So thank you very much. I will check the questions now. How did you run a new chart through Excel? Did you click on the existing chart and the option to rerun shows up? So I bet you're talking about this button. So in recent versions of XLSTAT, we have released this new button within all the result reports, so that are here. If you click here, you will get your dialog box, which is configured according to the result report where you clicked the button on. Can we add a trend line on the scatter plot? Yes, you have an option to do so in the dialog box. What is the benefit of variance over standard deviation? Well, variance is a bit more complicated to interpret compared to standard deviation. Standard deviation is more intuitive, as it's measured on the scale of the variable you're measuring. Whereas the variance has more interesting statistical properties that can be used in other statistical methods such as ANOVA. Can XLSTAT be used on Mac? Yes, we have a version on Mac. What is the difference between standard deviation and standard error of the mean? Standard deviation is the natural spread of your data, whereas the standard error of the mean measures how uncertain you are in estimating the mean of your population through a sample. Well, thank you so much for attending. I hope you enjoyed the webinar, and I really hope to talk to you once again next week. Bye-bye.